The objective of this study is to demonstrate how canola emergence and yield are influenced by pea placement, seeding depth, and environmental conditions that are different at each of the seeding dates. The seeding dates in our study were May 13 and May 28. Conditions seeding at the later seeding date were drier than the earlier seeding date. Seeding depths were either half an inch or 1¼ inches. There were 4 different pea applications, which were either a check with no applied P or 50 pounds of P2O5 per acre, which was either side-banded, split 50-50 between the sideband and seed placed, or was all seed placed. Now this would be well above our seed safe recommendation, especially for our seed master with only an 8.3% seedbed utilization. So accepting the no phosphorus check, each treatment got a total of 50 pounds of P2O5 per acre. Depending on the environmental conditions experienced, we were hoping to demonstrate some of the following. 1. Placing a large amount of phosphorus in the seed row increases the risk of seed injury, particularly if the conditions are dry. 2. Placing all the P in the sideband with the urea may reduce yield under cold conditions by delaying the phosphorus uptake until the ammonia toxicity of the urea dissipates. Or 3, placing some of the phosphorus with the seed and some with the urea in the sideband is going to be ideal. It's a hedge. It provides early access to P should the conditions be cold, but reduces the risk of seedling injury while still applying adequate phosphorus. Now, I've already crunched some of the data, so I know there are some interesting differences in treatment effects between the seeding dates. So let's have a look. Focusing on the main effect of seeding date, emergence was significantly higher at 82 plants per meter squared when canola was seeded early on May 13, compared to only 55 plants per meter squared when seeded late on May 28. Crop emergence was better at the early seeding date because soil moisture was higher in comparison to the late seeding date. While significant rainfall occurred 2 days after the early seeding date, 10 days had elapsed before significant rainfall was received after seeding late. The effects of seeding depth on canola emergence differ between the seeding depths, and this too can be attributed to differences in soil moisture. When seeded early, increasing seeding depth from half an inch to 1¼ inch significantly reduced canola emergence from 90.1 to 74.4 plants per meter squared, respectively. In contrast, increasing depth when seeding late significantly increased canola emergence from 50.9 to 60.5 plants per meter squared. Moister soil at the early seeding date likely favored shallow seeding, whereas seeding deeper to moisture at the late seeding date improved crop emergence. Seed-placed phosphorus was more seed-safe when applied early into moisture soil. When seeded early, emergence was significantly lower when all the P was seed-placed. Placing the whole 50 pounds of P2O5 per acre in the seed row versus the sideband resulted in 73.8 versus 86.8 plants per meter squared, respectively. This represents a decline in emergence of 15% from seed placing all the P. However, seed placed P was more injurious when seeding late into drier soil. Under these conditions, seed placing all the P resulted in 42.9 plants per meter squared emerging, compared to 67.5 plants per meter squared when all the P was sidebanded. This represents a larger decline in emergence of 37%. Moreover, emergence when only 25 pounds of P2O5 per acre was seed placed, the split P25-25, was equally poor at only 43.3 plants per meter squared. In other words, seed placing 25 pounds of P2O5 per acre was only causing seed injury when seeding late into drier soil, and not when seeding earlier into moisture soil. Here we're looking at the effect of phosphorus placement on canola yield for the 2 seeding dates. While seeding depth and phosphorus placement affect crop emergence, the effect had no detectable impact on yield. Canola is described as a plastic plant, capable of maximizing yield over a wide range of emergence. A plant density of 40 plants per meter squared is considered sufficient to maximize yield, and none of the treatments produced a plant population substantially lower than this level. While not statistically significant, added phosphorus numerically increased yield by 11%, so the site was modestly responsive to added P. Only seeding date significantly affected yield. Seeding late significantly increased canola yield by 12.5%, or 6 bushels per acre. The late-seeded canola may have benefited more from the late-season rainfall received in August. Conclusions. Seeding late into drier soil reduced canola emergence, increased the optimum seeding depth, increased seed injury to seed-place phosphorus. But none of these detrimental effects on plant population or different placements of phosphorus resulted in any detectable differences in canola yield. Regardless of treatment, plant populations were never low enough to limit yield, as canola is a very plastic plant, able to compensate for a wide range of emergence. Moreover, conditions at both seeding dates were warm, and background soil phosphorus was high at 14 parts per million. This means phosphorus placement would have less impact on early crop development and yield. After all, the crop only finds about 30% of the P you applied that year. So, if background levels are high, the crop is going to do well. It should be noted that a combination of seeding late into dry soil and seed-place phosphorus pushed the canola emergence down to around 40 plants per meter squared. We were really walking a fine line with these treatments. There really could have been a significant impact on yield if soil conditions had been drier, increasing fertilizer seed burn, or if there had been flea beetle feeding. Thanks to Sustainable Cap for supporting this project.